One way to think of electricity is to use a popular water spigot analogy. Because we can't see electricity, but we can see water, it helps us understand and comprehend how these things are actually working. So when water flows, we can measure the flow of water in gallons per second. And if we open a faucet for a period of time, the amount of water that is delivered is measured in gallons, right? How many gallon containers do you fill? For electricity, the amount of electric charge delivered is measured in a unit called coulombs. Now, there are 126 septillion water molecules in a gallon of water. That's a lot. And there are 6.2 quintillion electrons in a coulomb of electricity. Also a lot, because electrons are even smaller than atoms. So it'd be pretty frustrating to calculate changes in water or energy using these insanely, incomprehensibly large numbers. So instead, we convert these large numbers to units that are easy for us to think about. Gallons in the case of water, and coulombs in the case of electricity. Now that we know how to measure the amount of electricity, how do we measure its flow or current? Well, the flow of electricity is measured in amperes. And wait for it, an ampere is equal to 1 coulomb of electric charge per second. So instead of saying coulombs per second, like we might say gallons per second, so we just say an ampere. An ampere is 1 coulomb per second. Electricity is considered dangerous when the amount of electric charge gets very high. Now, why am I telling you this? Well, because taser devices have a unique relationship with current that allows us to keep them and tune them to be very effective yet safe. So unlike your wall outlet, which emits a continuous current of electricity, and that wall outlet might be attached to a nuclear power plant with a lot of power behind it, taser devices emit electricity in small bursts of electric charge coming from a small battery you might find in a digital camera. So each pulse from a Taser X2, for example, emits 63 microcoulombs of charge. And this means that the Taser X2, if we add up all those individual coulombs, comes out to 0.0012 amperes, or 1.2 milliamperes of current per second. This is actually quite a small amount of aggregate current compared to many devices we see and use every day. These pulses are delivered with a frequency that's high enough to stimulate the motor nerves that control my muscles, and that allows us to cause neuromuscular incapacitation. But these pulses aren't strong enough to cause physical damage to the body. Hence, with taser technology, we've found a way to use electricity rather than bullets to effectively and safely stop a threat.